Hello friends, now we are going to see what is metallurgy. Simply, metallurgy is the branch of science and engineering that deals with the physical and chemical behavior of metallic elements, their intermetallic compounds, their mixtures known as alloys. It involves the study of processes used to extract metal from their ores, then refine them and prepare them for practical use, whether in the form of pure metals or engineering alloys. Metallurgy connects core scientific principles with real world applications in industries like automotive, aerospace, defense, infrastructure, electronics, and healthcare. It is fundamental to human progress from the ancient bronze age to today's advanced superalloys used in the jet engines. Now we are going to see the historical backgrounds. The word metallurgy is derived from the Greek word metallon, meaning metal, and ergon, meaning work. So that means the working of metal. Historically, metallurgy is one of the oldest sciences. It began over 6,000 years ago with the human first using native metal like gold and copper. The discovery of smelting. So, what do you mean by smelting? Extracting metals from ores by heating marked the beginning of the true metallurgy. Over century, the metallurgy evolved through the Copper Age, Bronze Age, then Iron Age, Steel Age, and modern metallurgy. Now, we are going to see the branches of metallurgy. It is subdivided into the following types. The first is physical metallurgy. It focuses on the structural properties of the metals and deals with phase diagram, heat treatment, grain structure, mechanical properties that includes strength, toughness, and ductility. The second type of metallurgy is extractive metallurgy, extracting metals from ores through chemical and physical processes. It includes pyrometallurgy, high temperature methods, hydrometallurgy, chemical leaching using aqueous solutions. Third is electrometallurgy, using electrical energy. Now, the third type is mechanical metallurgy. It is the deals with the behavior of metals under mechanical forces. This includes stress strain behavior, then plastic deformation, metal forming. It includes rolling, forging, and extrusion. Now, fourth type is process metallurgy, related to the large scale industries production of metals and alloys involving smelting, casting, rolling, and other fabrication processes. Now, fifth type is powder metallurgy, a specialized branch where fine metal powders are compacted and sintered into final shapes. It used for precision components, porous materials, hard to machine alloys. Then, importance of metallurgy in modern industry. Metallurgy plays a critical role in almost every engineering discipline. Some applications include: the first is automotive, designing lightweight, strong material for fuel efficiency. Second is aerospace, development of high temperature superalloys. Then third is defense, armor materials, corrosion resistance in harsh environment. Fourth is biomedical, implants made from titanium alloys and stainless steels. Fifth is construction, steel reinforcements, corrosion resistance materials. Without metallurgy, bridges, skyscrapers, satellites, jet engines, and even smartphones would not exist in their current form. Now we are going to see the metallurgical processes from ore to metal. The first is mining and ore tracing. Ores are extracted from the earth. The next process is crushing, grinding, and concentration increase metal content. The second is reduction, removal of oxygen or other impurities. Then common methods: melting in a blast furnace, electrolysis, or chemical leaching. Third is refining, removing remaining impurities to produce pure metals. Techniques that are used in refining are electro refining, zone refining, vacuum distillation. Then fourth is alloying, mixing metals to improve properties. Some are examples: the steel, it is made up of iron and carbon. Bronze is made up of copper and tin. Brass is made up of copper and zinc. Then fifth is fabrication and heat treatment. Metals are cast, rolled, forged, or drawn into desired shape. Heat treatment, it includes annealing, hardening, tempering, alters the internal structure for desired mechanical properties. Next point is crystallography and microstructure. Metals are crystalline in nature, their properties depends heavily on their microstructure, which includes grain size, phase composition, dislocations, and defects. Metallurgists use tools like optical microscope, scanning electron microscope, X-ray diffraction, spectrometers. Understanding and controlling the microstructure is the key to tailoring the material strength, toughness, and corrosion resistance. Now next, challenges and advances in metallurgy. So some challenges are resource scarcity of key metals, that is rare earths, recycling and sustainability, corrosion and fatigue failure, high energy requirement for extraction. Then advances nanometallurgy, manipulating atoms to improve properties, additive manufacturing, 3D printing of metal components, smart alloys, shape memory and self-healing materials. Then green metallurgy, using eco-friendly processes and biology. Famous metallurgists in history: Georgius Agricola, 1494 to 1555, father of metallurgy, wrote Dara Metallica. Henry Bessemer invented the Bessemer process for steel production. William Chandler Roberts, Austin, known for austenite and work on phase diagrams. D. A. Potter and K. E. Sterling, modern pioneers in physical metallurgy. Educational and career path in metallurgy. So, some degrees and field of metallurgy, it is B or BTech in metallurgical or material engineering. Then MTech, MS in physical, extractive or process metallurgy. PhD for research and academic careers. Some career options are steel plants, foundries, and rolling mills, aerospace, automotive, defense sectors, research labs and metallurgical consultancy, non-destructive testing and failure analysis, quality control, welding, corrosion engineering. Conclusion: metallurgy is a more just the science of metals. It is the backbone of civilization, from ancient swords to modern jet turbines. Metallurgy has enabled us to mold the world to our need, with the challenge of the 21st century like sustainability, energy efficiency, and material innovation. Metallurgy continues to evolve and inspire. Now, here are some references that we derive the information above. You can see it. Thank you.